Earth. The moon plays a critical role in stabilizing our rotation axis so it doesn't flip back and forth like we see with the other planets in the galaxy.
Hugh, give us a number. What are the chances that all of these parameters can come together at just the right time in just the right planet to sustain complex life?
Well, Greg, there's about 147 different characteristics minimum that must be fine-tuned in order for physical life, not just life as we know it, but any kind of physical life to be possible on a planet, or even take an exotic site like a moon or a divorced planet. And the probability that all 147 characteristics would be met is less than 1 chance in 10 to the 186. Now, the Carl Sagans of the world will say, well, doesn't the universe have a lot of planets? Well, it does, but astronomers over the past 2 years have been able to establish a rather hard limit on the maximum number of planets in the observable universe. For example, we know that only 2% of the stars in our galaxy can sustain planets, could possibly have planets going around them. And so what that means is that the maximum number of planets that could exist in our universe is 10 to the 22. You take the 22, subtract from the 186, that leaves you with 1 chance in 10 to the 164 that you'll find 1 planet anywhere else in the universe with a capacity to support any kind of conceivable life. Only 1 chance in 10 to the 164.
Now, you gave us a large number, 10 to the 188th plus your other calculation. I mean, give us a sense. That's great for astronomers. For us plain folk, give us a sense of how big those numbers are or how small that chance actually turns out to be.
1 chance in 10 to the 164. It's 164 zeros after the 1. We need to realize that the universe itself contains fewer than 10 to the 79 protons and neutrons total.
You mean all the elementary particles, you add everything up?
Yeah, just the protons and neutrons.
In the whole
entire
universe.
Physical universe, it's only 10 to the 79. Or to put it another way, the probability of you being killed in the next few seconds by sudden reversal of the second law of thermodynamics is about 1 chance in 10 to the 80th. But we all realize that's such a tiny possibility that you're justified in not worrying about being killed by that sudden reversal. It's just never going to happen.
In layman's terms, there's just no possibility then.
The probability is indistinguishable from zero.
From zero.
There is no possibility.
So you're given the possibility or the theory that maybe ETs are involved in these things. Is the first problem you mentioned is, well, you got a probability problem of life happening by accident anywhere in the universe, just in terms of the origin of life issue. That was the first point you made. And the second point you made was...
Incidentally, that probability is also indistinguishable from zero.
So complicating that, the possibility that the conditions of life, for life rather, will be good anywhere else in the universe are also zero. This planet is a unique situation. So the bottom line is we could very well be alone in the universe. And in fact, that conclusion, if I understand it right, and Ken, I'd like to get your feedback on this, seems to be a growing consensus among professionals in the field.
That's right. And I think what's interesting about this, Greg, is that the extraterrestrial hypothesis assumes a naturalistic explanation of things, that life had some kind of natural origin, and that it would happen frequently and all over the place. But as you've mentioned, there is a growing consensus that this emerging anthropic principle is well supported in various disciplines.
It's not just coming from Christian research scientists. I mean, I wrote a book on this, The Creator and the Cosmos, where I discussed this anthropic principle and how hopeless the odds are of finding a home like Earth to support life anywhere else in the universe. But I'm not alone. Stuart Ross Taylor, this book, Destiny or Chance, drew the same conclusion. Dean Overman, A Case Against Accident and Self-Organization. And this book, written by a couple of University of Washington, well, it was an astronomer and a paleontologist, both coming from a non-Christian perspective, Rare Earth, drew the same conclusion. So regardless of the theological perspective of the astronomer or the physicist, they would agree with Paul Davies' assessment, an agnostic astronomer, that the evidence for design that's necessary for the support of life is utterly overwhelming.
But Hugh, let's just say for the sake of argument, there is this planet somewhere in the far reaches of the universe that managed to have life on it, survived, it's technologically advanced. Could these ETs be the explanation for the rUFOs that have yet to be explained?
No. I can think of 3 reasons. You got the distance problem, you have the velocity problem, and then you got the number problem. There's just way too many of these things.
Okay.
And in terms of distance, we're looking at hundreds of light years that these craft would have to travel. In the sense that we've already, as astronomers, been able to look at star systems that are close to planet Earth and recognize, based on the anthropic principle, they're non-candidates. Life can't exist there, so it's got to be beyond 155 light years from which these aliens would have to travel to. So that's a long ways through space. For example, take the fastest NASA spacecraft. We're looking at 112,000 years for that craft to travel that minimum distance of space.
But Hugh, this is just a technological problem. I mean, the world was large to people 50 years ago. Now the world's small. You can get around it in a day. Maybe 50 or 100 years from now, we'll have the technology to overcome these kind of problems in space travel, and therefore the ETs might have overcome it as well.
Well, the problem with transporting physical beings over interstellar space is you have to keep them alive, which means you must protect them from the cosmic radiation that exists in outer space, and you must protect them from the debris, the meteorites, the gas, and the dust that's out there. And the problem is, the faster you go, what you want to do, you want to cut down that 112,000 years to something that's more manageable. But the faster you go, the greater the damage to your craft and the greater the damage to the beings on board. And it goes up with the square of the velocity. So if you double the velocity, the damage goes up 4 times. If you triple the velocity, it goes up 9 times. And so realistically, and this is something I deal with in the book, there's no way a spacecraft housing physical beings on board could travel at greater than 1/10 the velocity of light. Well, if we're talking traversing, say, 200 light years, that means 2,000 years for a one-way trip. So this has already put you beyond one lifespan to make the trip. And moreover, there's no guarantee that you would get those people there and back alive. Even getting to Mars is technologically difficult in terms of the hazards of interplanetary space.
Plus, what you're saying is a lot of people think of space as being space, empty, but it's not empty.
It's not empty.
Filled with dangerous things.
It's filled with dangerous things, and the faster you go, the greater the damage you're going to take, which means that your spaceship is going to have thick armor plate on it in order to withstand the meteoritic impacts. And you're going to need something like lead to protect the inhabitants from radiation. And the faster you go, the more of this stuff you need. And then suddenly you got the problem of moving this through interstellar space. You're going to need a lot more energy, hence a lot more fuel to move this through space.
And when you have more fuel, you have more weight, and you have larger size, and it complicates the other problems.
And you need more fuel to move the fuel. So, the bottom line is, if you're talking a 200 light year trip, you're not going to make it with physical beings. No matter how much technology you have, no matter how much money you have, you're going beyond the limits of the laws of physics and the characteristics of the universe.
Now, Ken, Dr. Ross said there are 3 problems: the distance problem, the velocity problem, and then the numbers problem. How's the numbers problem work in here?
Yeah, you see the tremendous odds of even one craft traversing that kind of distance, but according to UFO phenomena, there are tens of thousands, possibly millions of crafts, and they're all slightly different from one another.
And they're all small.
They're all very small.
And they're small, they're not going to make it.
So how do we, that raises even another question, what kind of economic issues are we dealing with that a civilization, a so-called civilization, could send that many crafts? There are multiple problems with this kind of interpretation.
Yeah, one physicist calculated that another planet would have to send out 10,000 spaceships per year to account for even the minimum number of residual UFOs.
And part of what you're talking about economics is there's got to be a factory somewhere that's building these things, and how do you maintain that? And these are some of the practical problems a lot of people don't ever consider.
If they're intelligent, they're going to use the assembly line process. They're not going to make different handmade craft every time they do it.
That's right.
And is there something like standard vehicles that you see with the same characteristics, or is there a duplicity, or rather, is there a large variety of different?
An argument can be made that virtually every UFO that is perceived or observed is different from the next one. And that raises